In this chapter, we're going to learn how to design and implement methods. A method is similar to a function in other programming languages. In fact, they're really the same thing. But object-oriented programming languages use the term method instead of function. So we're going to be looking at how to design and implement methods in this chapter. If you're familiar with functions from algebra or mathematics, then you have a pretty good idea of what a method is. A method is just a set of programming instructions, code, that performs a named operation. And that operation can be anything from squaring a number to performing all sorts of much more complex computations. In fact, we're going to start this chapter with a very simple example of squaring a number to get comfortable with the terms and how to place method definitions in your Java programs. But the idea is that a method, like a function, takes data as input and returns data as output. The input data is transformed in some way and then output by the method at the end of the method's operations. So let's begin with a simple example, and let's learn how to write a method to square a number. That's a simple thing to do, but that way we can concentrate more on the parts of the method and not so much on what the method has to do. Methods have to be defined in a certain place in the Java program. They have to be defined outside of public static void main. So we can either put our method definitions before main or after main. I'm going to put mine after main just because it'll be easier for you to read them, but they can go before main as well. If we're creating a method that is not part of another object, then we start a method definition out with the keyword static. And static has a lot of definitions, and I'm going to postpone those definitions for now, but just understand that an independent method in a Java program has to begin with the keyword static. After that, the next part of a method definition is the return type of the method. What I mean by that is the return type of the data that's going to be returned. So if you're working with integers and you're going to return an integer, then your return type is int. If you're working with strings, then your return type is string, or char, or double, or whatever the data type is. Our square method is going to return int, so that's going to be our return data type. You follow that with the name of the method. So we're going to call ours square, because we want to square a number. So that's the third part. Next, we provide data that we want the method to transform in some way. This is called the parameter. Methods can have multiple parameters, but we're going to start off with a single parameter. So the parameter has to be defined by its data type and a name. So we want to take a number and square it, so our parameter name is going to be number, and we want it to be an integer that we're going to square. After this parameter, we're ready to begin the body or definition of the method, so we can put an open curly brace. I'll go ahead and put it up on the same line, but you could drop it down under static. The body of the method will be whatever the method needs to do. So in this case, we have a very simple definition for square. Take a number, multiply it by itself, and that becomes the square of the original number or the parameter. So we're going to make this a single line definition for this method, and so it's going to begin with the keyword return. Methods return data. Now, not all methods have to return data, but this particular one has to return an integer, because that's what we told it in this part of the definition when we said int. So to return data, we have to return it using the keyword return. And then to return the square of the number or the parameter, we simply multiply number times itself, and that becomes the number squared. So that's our definition. So we go down below and close off the definition, and that's how you define a method for squaring a number. Now let's look at how to use a method in a Java program. So we'll come back up here to main. We'll create a variable num. We'll assign it a value, 12. And then the simplest way would be just to use the method somehow. So we're going to write num squared equals plus, and now here we're going to do what's called a method call. So notice how that works. Where we want the number to be squared in that part of our program, we call the method. So I use the name square followed by the data that I want the method to work with. This is called the argument. So in the method definition, we have the parameter, and in the method call, we have the argument. The key thing to remember about parameters and arguments is they have to match in the data type and the number. So for example, in this square definition, I have one integer parameter. So in my method call, I need to have one integer argument, num. I don't have to put the data type. The data type is already declared back here when we declared the variable. I just have to make sure that I have a single integer argument to be sent to the square method. So what happens in the program, when we call square, the compiler actually transfers control to the method definition, and it executes the code. Well, first it checks to make sure that our parameters and arguments are matching. Then it executes the code inside the method definition and returns that value to the place where the method call is. A method call can go anywhere an expression is expected. So it can be on the right-hand side of an assignment statement. It can be inside a print, a concatenation like I've done here. Any place that an expression is expected, you can place a method call. So let's save and run this program and see what we get. Clear my screen. Chap 10 part 1.java. Java chap 10 part 1. So 12 squared equals 144. So you see what happened. We passed the value 12 to the method call. In the method definition, it multiplied 12 times itself to get 144, brought it back to this place right here, and then displayed the whole string, 12 squared equals 144. So that's a brief overview of how methods work. Let's go over the terms one more time. A method call begins with the keyword static if our method is not attached to an object or a class. We'll talk more about that later. Then we have the return data type for the method. Not all methods have to have return data types. You can have a method that performs a task without returning data. That's called a void method, and we'll talk about those later in this chapter. Then that's followed by the method name. After the method name comes the parameter or parameters that consist of the data that we're passing to the method. This is also called the parameter list because it could be one or more, and it actually can be 0. You don't have to pass parameters, but a lot of times you will. Then after that is the method body, which begins with an opening curly brace, and then whatever code we need to perform the task of the method. Somewhere in the method definition, if it's a data returning method, which this one is since we declared int right there, there has to be what's called a return statement. In this case, our whole method definition is a return statement because we're simply going to return the parameter multiplied times itself. Then to use the method, we simply have a method call where we call the name of the method followed by an argument where the argument matches the parameter list. So square has one integer parameter, so the method call square has to have one integer argument. So that'll wrap up this lesson on methods. In the next lesson, we'll look a little more in depth at declaring and using methods. Let's continue our discussion of methods by looking at two methods. One that converts a Fahrenheit temperature into a Celsius temperature, and another that takes a Celsius temperature and turns it into a Fahrenheit temperature. We'll develop those one at a time and test them as we go to make sure that they're working correctly. So we begin our definition of a method below or above main. I'm going to do mine below. We'll skip a space here. So we start out with the keyword static. The return type of the value we're returning from the function, we'll make that double. And we're going to call this one F to C to go from Fahrenheit to Celsius. And it will take a double temperature as its parameter. To perform the conversion, and we can do this again as a one-line program, but just to show the difference, I'll do it in a couple of lines. So let's start out by declaring a Celsius temperature, double Celsius, and then we're going to say Celsius is equal to, and the conversion factor is the temp, which will be a Fahrenheit temperature, minus 32 degrees times 5.0 divided by 9.0. All right, so notice how I use parentheses to make sure that the correct sub-expressions are computed first, and then we're going to return the Celsius temperature. And that's all I have to write for my function. So let's test the function. Let's prompt the user to enter a temperature. So I've imported the scanner class, so we'll create a scanner object first. One system in. Then we'll create a double Fahrenheit temperature and a double Celsius temperature variable. And then we'll say system out print, enter a temperature in Fahrenheit. And ftemp is equal to input dot next double. And then we'll say ctemp is equal to f to c ftemp. So ftemp becomes our argument that matches the parameter, both in number and in data type. So we have one parameter, so we have one argument. Our parameter is double, as is our argument. And then we can print out the result or display the result. So we'll write system out.println ftemp f is equal to, oops, I left out a plus sign right there for concatenation, ctemp c, close parenthesis and semicolon. I believe that's all we need to test this. So let's save the file. Then we'll compile it. Java C, chap 10, part 2.java. Left off a semicolon right there. Okay. Again, following my policy to never hide my own errors. So we fix it. Let's compile again. There we go. So we'll do something we know. 32 Fahrenheit should be 0 Celsius. 32.0 F is equal to 0.0 C. Let's try one more. 212 Fahrenheit, that's boiling point, should be equal to 100 Celsius. And it is. So we have the Fahrenheit to Celsius function working correctly. And this is a very good example of a typical function where we want to perform some named task, Fahrenheit to Celsius, that we don't want to clutter up in the main program. I haven't really talked much about this reason for methods yet. But one of the things you want to do when you're writing your programs is keep your main program as small as possible, as easy to read, and as clear as possible. And one way to do that is to take as many possible computations out of main and put them into methods. So that's what we're doing here. Rather than having this code in our main program, we put it up in main. What that does, besides cleaning up our code, is lets the reader of the program decide for themselves whether they want to go through the task of understanding what F to C does. If they don't care, then they can just skip it. If they do care, they can find the method definition and read how it works. So now let's write a Celsius to Fahrenheit function also. So we'll start off static double, this is C to F, double temp, double Fahrenheit as our variable, and then we're going to write Fahrenheit is equal to, and the conversion function for that is the temperature, the Celsius temperature, times 9.0 divided by 5.0 plus 32 degrees. I started off with the parenthesis there. We don't really need that. The one parenthesis we need is we need this division to happen before this multiplication. So we do need those parentheses there. That's the only set we need. And then we're going to return the Fahrenheit value. And we'll talk a little bit more about returns in a second. When we close the body, let's comment out this code, just because I don't want to have to create a new scanner object, and I need one if I'm going to be inputting multiple versions. Plus, I don't want to run that code again anyway. So here we're going to say system out, print, enter a temperature in Celsius. ctemp is equal to input dot next double. And then we'll write ftemp is equal to C to F ctemp. There's the function call, and again with the correct argument. And then we'll write system out println ctemp plus C is equal to ftemp plus F. Semicolon to end the statement. All right, looks right. We can fix it if it's not. Let's compile. Let's clear the screen first. Compile. Whoops, there we go. That's just a little typo. Print. Save. Clear the screen. Try it again. There we go. Chap 10, part 2. So 0 Celsius should be 32 Fahrenheit. Let's run it again. And 100 Celsius should be 212 Fahrenheit. I just use boiling and freezing points as easy numbers to test. Let's review again a method definition. We start out with the keyword static to indicate that this is not part of a class. There's another meaning for static inside classes. We'll look at that later in the course. Then we have the return type of the function, followed by the function name, followed by the parameter list. In this case, it's just one parameter, a temperature. Then we open the method body, then we perform the task, and then finally, all value returning methods have to have a return statement where the value that the method computed is returned to the calling program. So that's what we have, where we have return Celsius, or in the example of C to F, return Fahrenheit. And then we close off the body of the method with a closing curly brace. And then the method call is where we want the method to perform its computation, and we can put that any place an expression is expected. So in this case, we're putting it on the right-hand side of a assignment statement, here and here. And then the data passed into the method call is called the argument, and we have to make sure that that argument matches the parameter in data type and in number, so that if we have more than one parameter in our parameter list, we have to have an equal number of arguments in the argument list in the method call. So there's another good example of how methods are written. What I want to do in the next lesson is look at a couple of method calls where we have more than one parameter. And in fact, we'll start out with an example from this Fahrenheit and Celsius conversion example that we're looking at right here. And we'll do that in the next lesson.